Have you ever wondered why you can't tickle yourself? It's a curious phenomenon, isn't it? Normally, when someone else tickles you, you might squirm with laughter, but try it on yourself, and well, nothing much happens. So, why exactly can't we tickle ourselves? Let's unravel this mystery with a little help from science. The sensation of tickling is unique. It's a strange blend of pleasure and pain, laughter and squirming, all mixed into one. But to understand why self-tickling doesn't work, we need to delve into the workings of our brain, particularly an area known as the cerebellum. The cerebellum is the part of our brain that is primarily responsible for controlling movement and balance. It has an incredible ability to predict sensory consequences of our own actions. When you attempt to tickle yourself, the cerebellum already knows what's coming. You see, when you move your hand to tickle yourself, your brain sends signals that it's about to experience a certain sensation. The cerebellum essentially sends an advance notice to rest of the brain, preparing it for the incoming touch. This forewarning causes your brain to downplay or even ignore the sensation. As a result, the element of surprise, which is a key component of being tickled by others, is completely eliminated. You aren't caught off guard by your touch, making it impossible to elicit the same ticklish response that you'd experience if someone else did it to you. This process is also why sometimes, when you walk in a dark room, you might get startled by someone else's touch, but not by your own. Your brain isn't prepared for unexpected external stimuli, and that's what can induce that ticklish reaction. But why does tickling still work when others do it? This comes down to unpredictability. When someone else is involved, you don't have a full grasp on how intensely, where, or when they will tickle you. That unexpected factor keeps your brain on its toes and unable to adjust or ignore the sensation. Surprisingly, this brain function serves a helpful evolutionary purpose. It's a way for us to distinguish between our own actions and those caused by something or someone else. Our ability to predict the sensory outcomes of our movements allows us to better interact with the world, providing a seamless and controlled means to execute movements without surprises. Intriguingly, some researchers believe that tickling is an evolutionary mechanism designed to encourage social bonding and play fighting, particularly among younger individuals. This is why children, who are more prone to play and social interaction, are often more ticklish than adults. In terms of practical applications, understanding this mechanism has implications in the field of robotics, neurological studies, and psychological therapy. Robots with advanced prediction algorithms could interact more naturally with the world. Meanwhile, insights into these neural processes can improve treatments for sensory disorders. Moreover, this understanding furthers our overall knowledge of the brain's incredible predictive capabilities, showcasing the intricate ways in which our bodies anticipate and respond to even minor stimuli. To boil it all down, you can't tickle yourself because your brain is too smart for that. It anticipates the sensation, nullifying the surprise factor that makes tickling so effective when done by others. In the grand design of nature, this is yet another reminder of how our nervous system is wired for precision, safety, and social interaction.